Okay, here we go. Yesterday was a pretty important class, the tangent ratio, your introduction to trig. So today we finish that intro class and we get introduced to the other two trig ratios that should be very familiar with you because right next to the tangent button on your calculator were the other two. Good news, bad news story. Good news, well, bad news is that it's two more ratios that you have to learn. But the good news is that the procedures, if you understood how to do tangent, well, the other two procedures are equally done in a similar fashion. So there's really nothing new to learn other than the two ratios today. All right, so here's your homework. Okay, so the sine and the cosine ratio. So yes, mathematicians are lazy. We would say we're efficient. We don't want to write the whole word sine, cosine, and tangent. So in our calculator, we write sin, cos, tan. But they stand for sine, cosine, and tangent. And remember that the tangent and the sine and the cosine we'll find out today are simply, by definition, defined as a specific ratio of a right triangle. So there's nothing to prove here of what sine, cosine, or tangent is. We simply make a definition of what they are, and we run with it. All right. So as I said yesterday, I love trig. It's fun, especially when it's the basic trig right here. We get to pre-calculus, calculus. We get some really challenging trig. I find that fun as well too. But a lot of people are overwhelmed with that trig. All right. Quick recap. Trigonometry comes from the word trig and metry, trig for triangles, metry for measuring. We're going to be measuring triangles. This year, we will restrict ourselves to right triangles. Trig applies to all triangles. However, we're going to restrict ourselves this year to right triangles. So remember how this procedure works. We start with a right triangle. We won't be messing with the 90-degree angle. We'll be messing with the other two angles. In this case, angle C and angle A. Remember, when the angle is unknown, we like to use, instead of the variable x, we like to use the Greek letter th, theta, to represent that unknown angle. So as soon as we pick angle A for that theta, then it establishes the names of the three sides of the triangle. Now, the hypotenuse is always called the hypotenuse, but as soon as you pick your theta, then the side next to theta, that's not the hypotenuse, is called the adjacent side, and the side that is opposite, not very inventive or creative, but it's called the opposite side. So we have adjacent and opposite side. Now, those sides, opposite and adjacent, will switch. If theta is next to the C, hypotenuse remains the same. The adjacent side now is the side BC, and the opposite side is side BA. So hopefully with tangent, you became very familiar with that idea. Today just introduces two more. So quick review on tangent. Remember, by definition, it's a definition. It's not a proof. It's not a theorem. By definition, tangent is defined as the opposite side of a right triangle divided by the adjacent side, and it's a fraction. We can use tangent in two ways. We can solve for an unknown side, and we can solve for an unknown angle. When we're solving for unknown sides, we need one angle and one side. When we're solving for an unknown angle, we need two sides. So, for example, look, I've got one known side, or the length of 14, and one unknown side, x, and I have one angle, 15. So as soon as we establish that one angle, and we see that we have the opposite side and the adjacent side, now you might argue we don't have the adjacent side, it's x, but that's the side we're trying to calculate. We plug in our values. So the tangent of 15 is equal to the opposite side's length over the adjacent side's length. And then we simply solve for x. Remember the pattern: when x is in the denominator, we multiply both sides by x. On the right side, the x's cancel. On the left side, we now need to get rid of the word tan 15. We get rid of the tan 15, not tan, but tan 15, by dividing both sides by tan 15. On the right side, or sorry, on the left side, the tan 15 cancels, and on the right side is what we plug into our calculator. Plug that into our calculator, 14 divided by tan 15, and we get 52.2. Always remembering that our calculator, at least for this year, must be in degrees, not radians. All right, and then lastly, the second thing we learned yesterday is how to solve for an unknown angle. Notice x there is unknown. You might be arguing or wondering, why didn't they use theta? Well, they could have, but they chose x this time. Let's see. So tangent of x would be equal to the opposite side divided by the adjacent side. So that would be 3 divided by 3. Now, this one is different in the sense that I'm not trying to get rid of tangent of an angle. I'm trying to just get rid of the word tan. So if you're just trying to get rid of the word tan, so you leave x, then this is when we're going to use inverse tangent. Most students remember this by, I'm solving for an angle, I'm going to use inverse tangent. I'm solving for a side, I'm going to use tangent, not the inverse. Remember, the inverse button for tangent is directly above the tangent button. You got to use the second function. All right, let's see. Inverse tan and tangent are inverse operations, so they cancel each other on the left side. So we're just left with x. And on the right-hand side, that's what we type into a calculator. And most students, as soon as you do a few of these, simply right from the very start, because they know how this works, simply do inverse tangent of opposite divided by adjacent. So 45 degrees. So today, the only difference is we get 2 more ratios. And the ratios are called sine and cosine. So in your book, Truth, remember, this is a definition, not a theorem. Sine. Sine is simply, remember yesterday under tangent, we never used the hypotenuse. Now we're going to use the hypotenuse. Well, there's 2 sides that we could use with the hypotenuse, the opposite or the adjacent. So we get 1 trig ratio for each one of those. So by definition, we are going to define sine as the opposite side divided by the hypotenuse. And remember, when we say the side, we're talking about the length of the side. So sine is the opposite over the hypotenuse. Cosine, you pause and write that down. Cosine is the adjacent divided by the hypotenuse. Now, since you're probably curious and you probably wonder yourself, are there more of these? There are. You won't see it on your calculator, but you might see these if you were ever doing a Google search of trigonometry, or you're opening up a higher level trig book. There are more trig functions, just sine, cosine, and tangent. But this year, those are the 3 that we learned. Okay, so all we have to do now is simply do some examples, and that's kind of it for today's class. So remember, there are 3 trig ratios now, sine, cosine, and tangent. So the first thing I'm going to do is just introduce you to a way of how do you remember the 3 trig ratios. So this is probably what, if you ask your older brother, sister, mom, or dad about trig, this is what they remember. Okay, so sine is defined as the opposite of the hypotenuse. Cosine is defined as the adjacent over the hypotenuse, and tangent is defined as the opposite over the adjacent. That's a lot to write and a lot to remember. So what we do is we take the first letter of each one of those words. I'm going to take the first letter of each one of those words. In other words, I'm taking the S, the O, and the H, the C, the A, and the H, and the T, the O, and the A, and make 3 words. 3 words for all 3 of those trig functions. And this is probably what mom and dad remember when they were doing trig. And it's the word SOHCAHTOA. So SOH tells you how to write sine, opposite over hypotenuse. Ca, C-A-H, ca. So cosine is the adjacent over the hypotenuse, and toa would be tangent, would be the opposite over the adjacent. So if your mom or dad were looking over your shoulder, they probably were whispering to you SOHCAHTOA from the very start. And yes, that's how you remember those 3 basic trig functions right there, SOHCAHTOA. All right, so if you remember, the first thing we did yesterday after we were introduced to tangent was a silly thing where they just simply had you write the ratio. You didn't actually calculate anything. They simply had you write the ratio. Now, why do we go through that trouble since it doesn't really accomplish anything? It's so that you can at least ensure, or we can at least be assured that you're setting up the ratio correctly. If you set up the ratio incorrectly, you obviously won't get to the right answer. All right, so let's see. I'm going to go upper to lower, and then from left to right. So the first one says sine of angle A. So angle A, and it says sine. Let's see, SOHCAHTOA. I need opposite over hypotenuse. So in relationship to angle A, the opposite side would be the 3, and the adjacent, I'm sorry, the hypotenuse, almost did tangent. The hypotenuse would be 5. So 3 over 5. You see how I did that? All right, sine of C. So sine of C, I'm looking at angle C now. It's still opposite over hypotenuse, but I'm C, so the opposite side would be 4, and the hypotenuse would be 5 again. All right, how about the cosine of A? Back to angle A. So let's see, cosine. Cosine, oh, it's adjacent over hypotenuse. So the adjacent to A would be 4, and the hypotenuse would be 5. Remember, the hypotenuse is always the side opposite the 90-degree angle. Cosine of C adjacent over our hypotenuse would be 3/5. And lastly, from yesterday, we did the tangent. So let's see, opposite over adjacent. For angle A, opposite would be 3, and adjacent would be 4. And let's see, tan of C would be, well, just be the reverse of that. That would be 4/3. Now notice the tangent of angle A and angle C are reciprocals of each other, 3/4 and 4/3. But on cosines and sines, those two are not reciprocals of each other. So tangent is kind of unique in that fashion. It's simply because it's opposite over adjacent. Okay, so if you can set these up correct, and I had some more practice, so I'm going to go ahead or ask you to pause it, write these 6 out, and then start the video. This is just practice. All right, so the answers to all 6 of them are as follows. If you made a mistake, hopefully you can identify your mistake. If not, send me an email asking where, or just tell me where your confusion was and let me help you out there. But I'm assuming that you got this. This is not too challenging. But if you can't set up the ratio, you can't do the problem. All right, so now let's actually calculate something. Remember, there's 2 things that we do. One is we solve for a side, and one is we solve for an angle. So recall that when we solve for a side, it's going to be, the setup will look something like this. The sine of a specific angle is equal to one of the numbers will be missing, and we assign it x. All right, when we solve for an angle, we use the inverse function, and it will still be the same ratio. In this case of sine, it would be opposite over hypotenuse. So for solving for a side, we have to do a little bit of algebra. Most students, after they do a bunch of these, notice there's a pattern of what divided by what. And absolutely, I don't teach the pattern, but if you notice the pattern, absolutely run with it perfectly fine. But for solving for the unknown angle, it's just literally inverse whatever the function is and just follow the directions of opposite over hypotenuse for sine, adjacent over hypotenuse for cosine, and opposite over adjacent for tangent. Okay, so let's do a couple of these, and there's really not much left. Just do solving for unknown side, unknown angles, and we're done. So recall from last class for tangent, remember, if we're solving for an unknown side, yesterday all we knew were tangent. Here's a tangent one. So let's see, opposite over adjacent. I know what the angle here is. It's 56. So solving for y, I simply need to multiply both sides by 32. The right side, 32's cancel, and on the left side is what you plug into your calculator. Away you go. All right. Remember the one that's tricky, and I think I've showed you this one before, just a repeat, is when the variable's in the denominator, we simply multiply both sides by the denominator, or by the variable, sorry, which is the denominator, and then we divide by tan 15 in this case. That's what you plug into your calculator. Remember, fractions are division symbol, or the fraction bar is a division symbol. Okay, so now we're going to put it all together, but we're still just going to solve for a side. We'll do angles next. So when solving for the side of a right triangle, typically the problem is going to look like this, where you're given one side, one angle, and there's 2 variables there, a y and an x. It doesn't really matter which one you solve for first. This is telling us to solve for x. So here's what I would suggest you do. If not literally, then this is what goes on in your head. Step number 1 is to identify the known angle. The known angle here, if we're solving for x, is 67. Well, x in relationship to 67 would be the opposite side, and the known side length would be, in this case, the hypotenuse. So as I think about my 3 trig functions, I just gave you the answer. If I think about my 3 trig function, I'm looking in blue here, opposite hypotenuse. There's only one of them that says opposite hypotenuse, and that's the sine. So that's how you know to use the sine and not the cosine or the tangent for this one. All right, so let's see. Set it up. Opposite is x. Hypotenuse is 120. Oh, this is the one we like, where we simply multiply both sides by 120. 120 is on the right, cancel. And on the left side is what we plug into our calculator. So we take 120 sine 67. Now remember, mathematically speaking, that is 120 times 67. But the calculator knows if you put them next to each other, that means multiplication. All right, plug that into your calculator. You will have to round. And we got basically 111 degrees rounded. So let's see that again. For x, once again, the process is find the known angle, 67. Find the relationship between x and 67. X is the opposite side. And then what's the relationship between 67 and the known side? The known side is the hypotenuse. Set it up, do a little bit of trig, or do a little bit of algebra, and you get your answer. All right, so here's another one, same problem, but solving for y this time. All right, so solving for y. So let's see, the procedure is I circle the known, I'm solving for y, I'm going to circle the known angle. I state the relationship between y and 67, that's the adjacent side, and then I state the relationship of the known side. The known side is 120, so that would be the hypotenuse. And then I think about the three trig functions, which one uses the adjacent and the hypotenuse, and that would be cosine. So now I plug in the known angle for A, that would be 67. The sides that are listed there, y is y, and the hypotenuse is 120. And then I go to town with my calculator and do a little bit of algebra. Multiply both sides by 120. The 120s cancel. And at this step, most people would be grabbing their calculators right now. So 120 times cosine 67, and I'm getting 46.9. Good? All right. Recall the second thing we do today is we solve for an angle, and recall from last class for tangent, we're solving for an unknown angle. We do tangent of that unknown angle is opposite over adjacent, so that would be 3 over 3. Yesterday, we didn't have to worry about which of the three it was always tangent. We're solving for x here, so to get x by itself, we need to get rid of the word tan, and to get rid of the word tan, we take the inverse of both sides. Inverse tan of both sides. On the left side, inverse and tan cancel each other, and on the right side is what you plug into your calculator. So inverse tangent of 3 over 3 is 45 degrees. Okay, so let's see what that looks like if we don't know which trig function to use. So here's an example where I have an unknown angle n, and then they give you two sides. They have to give you two sides. So let's see, 40 and 22. So in relationship to angle n, I'm solving for n here. In relationship to angle n, 22 is the opposite side, and 40 is the hypotenuse. So I think about my three trig functions again. Which one uses opposite over hypotenuse? It's our friend sine again. Now, if you know what this turns into, you can immediately jump to plug it into your calculator. I'll show you the whole drill here. So let's see. Sine of n, right, would be 22 over 40. I know I need to take the inverse of both sides. So let's see. The opposite would be 22. The hypotenuse would be 40. That's what I plug into my calculator. And there you go. There's your answer. All right. Now this one looks more tricky simply because, look, I don't have any angle, and I have all three sides, not just two sides. I have three sides. Now it says calculate the unknown angles. Well, the unknown angles there are angle A and angle B. It doesn't really matter which one you do first. I guess I'll do A first. Now, since we have the option, we can pick any two sides. It doesn't matter which two you pick. We have three trig functions. Whichever one floats your boat, go for it. So if I stick with sine, then I'm going to use the opposite over hypotenuse. Adjacent over hypotenuse for cosine, and opposite over adjacent for tangent. And it does not matter which two sides you will get. And I would ask you to explore with your calculator. Once we do the first one, put it on pause and try any of the other two trig functions and see if you get the same answer. So if I do inverse sine, that would be opposite over the hypotenuse. That would be 3 over 5. Plug that in, away you go. I got 36.9 degrees. If we do it for angle B, let's see, angle B, if I want to use sine again, let's see, that would be opposite over hypotenuse. So the opposite side for B would be 4, and the hypotenuse would be 5. Plug that into your calculator, and there you go. Now, if you're really on the ball, maybe you gave this some thought, why in the world would we need trig to find angle B if we knew angle A was 36.9? If we knew angle A was 36.9, we could have subtracted that from 90, because remember, A and B must be complementary in a right triangle, and you would have gotten 53.9. Now, Maybe you realize that, maybe you didn't. But when the homework is done like this, where they ask you to solve for both of them, you have some options here. Hopefully that made sense. If not, rewind, play that one again. All right, are any of these challenging? Let's see. It says calculate the altitude of all three sides. So remember, altitudes go from a vertex to the opposite side and make a right angle. So since the triangle has three sides, there's three altitudes. There's the altitude from top to bottom, right? We know that if it's a isosceles triangle, then all altitudes break the bottom portion, not the two legs, but the third side in half. So I know that side is 3. So let's see, how can I calculate the altitude of that red line right there? Well, I know it's a right triangle. I have two sides. I could apply the Pythagorean theorem for this one. This is one of the homework ones. So if the altitude we're going to call is B, then I know that 3 squared plus B squared equals 8 squared. I almost said 6 squared. And then that's a simple trig problem. Subtract 9 from both sides. So the square root of 55. If they say, give me the exact value, that would be the square root of 55. If they say the approximate value, you do some rounding. All right, so it looks like that isn't too hard at all. Why is this called a challenging one? Well, because if we go from either the left side or the right side and we make an altitude, that's what we get. Oh, geez, boy, that's a ugly one right there. How in the world are we going to do this? Well, this is why this is in the trig section right here. So remember, we know that the angle that I'm pointing right there, because it's an isosceles triangle, would be equal to the angle right there. I mean, it would be the same angle. It's the same darn triangle. So if I could somehow figure out what that angle was, then I could use some trig, because remember, all you need is one side and one angle to calculate an unknown side. So that's what I'm going to do. So I'm going to call that angle theta. It would be the same one on the other triangle. And if I could calculate that angle right there, theta, I could plug it into my second triangle there and use a little bit of trig to figure out what the altitude was in the middle one. Okay, so let's do that. So let's see. Well, we know that side right there is 3. Cool. Oh, I want to calculate an unknown angle. Now I know one side is 3 and the hypotenuse is 8. So I could use inverse cosine adjacent over hypotenuse to figure out what theta is. So inverse cosine of 3/8 gives me roughly 68 degrees. So now I know that angle is 68 degrees. Now, why did I go to all that effort to find out that was 68 degrees? Because to find the red line right there, I need to know one angle and one side, well, other than the 90 degree, one angle and one side. And since the bottom was 6, that's the hypotenuse of that triangle, I needed another angle. So that's how I figured this one out. Okay, so let's see. To finish this one, to figure out how long is the altitude of the red line right there, we simply need to see what we've got in relationship to that angle right there. We have a hypotenuse, and we want to calculate in relationship to 68 the opposite side. So let's see, the opposite side over the hypotenuse would be sine function. So sine of 68, right, would be equal to the opposite side x over the hypotenuse. In this case, that would be 6. Yay, this is the one we like, right? Multiply both sides by 6. The 6's cancel. Grab your calculator. 6 sine 68 would be how long x is, and it's 5.6. Now it says calculate the altitude of all 3 sides, but if you look at the triangle that we were given, which was isosceles, notice that the other altitude from the lower right to the opposite side would be exactly the same thing, so it would be 5.6 as well too. So this was a challenging one simply because you need to think about how to solve this one. All right, so that was the lesson for today. There's your homework. If you're running any problems, send me an email. If not, then I will see you tomorrow for your next class.